and it's Robert Naeye. Robert, take it away.
Okay, great. Thanks. Can everybody see my slide here?
Yeah.
Yep.
So we're good. 3 roads to extraterrestrial life. Everybody can see it okay?
Yep.
Yes.
Okay, great. Well, I'll just jump right in. So, first of all, I just want to thank Ted and Al for inviting me to give the presentation tonight, and Ted for connecting with me earlier today to make sure all the technology would work. And it's a really pleasant evening out there, so I want to thank all of you for tuning in tonight. I wish I could be there in person like I was 2 years ago, but it's good to connect with the RAS again, even if it's just virtually. So I've got a lot of ground to cover in about 30 to 35 minutes, so I'm going to just jump right in. So as Ted mentioned, my talk tonight is based on a cover story I wrote for the September 2020 issue of Astronomy magazine. I'm not sure if it's on newsstands right now, but you can always order it online. So if you're interested in this topic, you can, read the article. There's also an accompanying web article I wrote as well that actually has material I'm not going to really discuss tonight, but which might be of interest to you. So my topic tonight is how scientists might find life on other worlds. And I think we all know for centuries, scientists have discussed and debated and deliberated about the prevalence and nature of extraterrestrial life. And the public, of course, is very interested too, given the popularity of movies and stories that depict alien creatures like E.T., Star Wars, Close Encounters, etc. But despite all of this interest and speculation, I like to liken astrobiology to string theory. It's a science whose subject matter has not been proven to exist. We really don't know who or what is out there or whether life is common or rare. People talked about it, written about it, but we really don't know. So what we need to do is we need to turn astrobiology into an observational science, which means we need to find out what's up there. So as my astronomy article explains, scientists are taking 3 different roads or approaches to search for extraterrestrial life. So imagine this road veering to the left is searching in the solar system. Number 2 is probing the atmospheres of exoplanets. Those are planets orbiting other stars in search of biosignatures. And the really fun part is the 3rd road off to the right is the search for technosignatures from advanced civilizations. So I'll talk about that toward the end. I want to make it clear though, this is not a race or competition. We don't know how common life is, or it's impossible to predict how soon we'll find it or who will make the first detection on life on another world, or how it will be made. We just don't know. But I can tell you that our technology is getting better and better. So if life is relatively common, we might make the first definitive detection in the next 10 to 20 years, hopefully in my lifetime. I'm 57 right now. I'm hoping this happens in my life. So of course, all of you are wondering, well, haven't we already detected extraterrestrial life? And the answer is no, at least nothing that's been proven or confirmed. So I think it's probably a lot of you have read, last week an international team of astronomers announced the detection of the molecule phosphine in Venus's thick atmosphere. That's pH3. So this slide shows the 2 spectral signatures, one in white, one in blue, of 2 different telescopes superposed on an image of Venus. The 2 different telescopes that detected this spectral signature. But I need to emphasize that, and I listened to their press conference, this discovery team made it very clear they did not detect life on Venus. What they said they detected is they've detected phosphine gas at a fairly high level of confidence. Now on Earth, phosphine gas comes either from microbes or human industrial activity. And the team tried to rule out all known processes that are non-biological on Venus that could produce this observed phosphine. But this phosphine was found in an atmospheric layer about 30 to 40 miles above the surface, where, as far as we can tell, there's virtually no water, and it's dominated by clouds made of sulfuric acid. So it could be some kind of chemical reaction that we don't see on Earth that's producing the phosphine. We really don't know. So basically what we have right now is the detection of phosphine with no explanation for what is producing it. Life is one of the possibilities, but right now we just don't know. It's going to take follow-up missions to Venus, maybe like a balloon mission or some kind of sample return of gas in the atmosphere 30 to 40 miles high before we can answer this question. So I'm just going to say that this is unresolved right now. So I'm going to really start off with the solar system and start off with Mars. And I think, as all of you know, probably many of you have been observing and imaging Mars in recent weeks, is, you know, the planet comes relatively close to Earth every 2 years or so. And it makes it relatively easy to observe, makes it relatively easy to observe with spacecraft. And for long stretches of history, many people, including learned scientists, just assumed that Mars is inhabited, maybe by intelligent beings or by a vegetation. But the Mars, you know, the NASA spacecraft that orbited, that flew by Mars and then orbited Mars in the late 60s into the 70s, showed that Mars's surface is cold, dry, barren, and completely lacking in any obvious signs of life. But here we see two orbital photos from Viking that show channels that look suspiciously like channels, streams and rivers on Earth carved by water. And I think, as probably many of you also know, that spacecraft, you know, observations from the surface by landers and especially the NASA rovers have really proven, I think beyond all doubt, that liquid water once flowed on Mars. So, you know, on Earth where we find water, we find life. So this makes the red planet a plausible host for past or current life. So in 1976, two Viking landers touched down, two NASA missions, the very first successful landings on Mars. On the left, we see a model of a Viking lander, and on the right, we see an image from Viking 1. That big boulder in the distance is named Big Joe. That remains my favorite rock on Mars. Now, both Viking landers came equipped with mechanical arms that you can see here in the image. They scooped up soil samples, brought them inside the lander, and then each lander had 3 experiments to search for life, you know, to look for metabolism basically, and also an instrument to look for organic material. Now, this is what's really interesting. One of the biology experiments, the labeled release experiment, returned from both Viking sites that were 4,000 miles apart, returned data highly consistent with the interpretation that there's life on Mars. The problem is the other 2 experiments were negative, and the experiment to detect organic chemistry came up negative. So most, but not all, scientists concluded no organics, no life. Therefore, the positive results of this labeled release experiment, they were attributed to some kind of active chemical agent in the Martian soil. But I want to make it clear, and I've talked to astrobiologists about this, it's unclear. It's possible that we've already discovered life back in 1976. I actually find this result a lot more compelling than the Venus results announced last week. And what I'm really disappointed is that NASA's taken a very conservative approach. They don't want to repeat ambiguous biology results. So NASA has never since sent a dedicated life detection experiment to Mars to follow up these results. Now, many of you probably also remember, go back to 1996, a team of NASA and Stanford scientists announced that they had found chemical signatures of past Martian life inside this meteorite, ALH84001, which definitely came from Mars. And you can see on the right, they even found these little incredibly tiny tube-like structures that they interpreted as possible fossilized nanobacteria. Now, this life would have dated back several billion years ago, back to when Mars had water on its surface. Now, these claims remain controversial to this day because all the signs of life can also be explained by non-biological, just regular chemical processes. So I would say that this is still kind of an open question. Now, much more recently, telescopic observations from Earth and measurements on Mars from NASA's Curiosity rover have detected trace amounts of methane in Mars's thin atmosphere. And as you can see in this illustration, that methane rises and falls with the seasons. Now on Earth, 95% of the trace amounts of methane in Earth's atmosphere are of biological origin. The problem is, of course, once again, there's a number of chemical or geological processes that can produce methane that don't have anything to do with life. Also, this is amazing. Last year, the same Curiosity rover also discovered free oxygen, trace amounts, but there's trace amounts of oxygen in Mars's atmosphere, which rises and falls in tandem with the methane. And of course, on Earth, almost all the methane in Earth's atmosphere also comes from biology. So we have these tantalizing results, but right now we can't say for certain whether we found life on Mars. So in less than 2 months ago, on July 30th, NASA launched its next Mars rover, Perseverance, or they call it Percy for short, to go to Mars, and it'll land in February 18th of next year. So here's a piece of art depicting Percy on the surface. Now, Percy's going to land in Jezero Crater, and you can see that inside this crater, it's not that little crater in the middle, it's kind of the big crater that's kind of offset to the right. Inside this crater, you can tell, it's obvious from the orbital image that this is an ancient river delta. So Curiosity should come across lots of rocks that formed in liquid water billions of years ago. Now, despite what NASA says, Percy carries not a single instrument that's really dedicated to searching for life, or really that's capable of detecting microscopic life. It's sort of being touted as this life mission, but it's really not. But what it will do is collect rock and soil samples for later return to Earth. So here's a nice artist rendition of a sample return mission that NASA and the European Space Agency are planning right now. This thing would, if it goes on schedule, it depends on funding and politics as much as science, we'll have samples back on Earth in the 2030s. And as one of the team members I quoted in my astronomy article, Jim Bell from Arizona State University, he said that as far as he's concerned, Percy's mission won't be complete until its samples are brought back to Earth. So according to the current mission architecture, NASA will provide a rover that'll go to Mars, collect the samples that Percy's gathered, put them on a little rocket, blast it into Mars orbit, and then the European Space Agency will provide a spacecraft that'll rendezvous in orbit with this sample vehicle and then return it to Earth. I mean, this is obviously an extremely challenging mission technologically, but if it works, we could have Martian samples that scientists can study in our best laboratories right here on Earth sometime maybe 10 or 15 years from now. If these samples contain traces of life, past or present, we'll answer the life question. If not, doesn't rule out life on Mars, but it could prove life, current or past life on Mars. Now, the European Space Agency is planning its own rover named Rosalind Franklin. She was the great British scientist whose X-ray imaging in the 1950s made possible Watson and Crick's discovery of DNA's double helix structure. So this rover was actually originally scheduled to launch earlier this year and arrive early next year, but the Europeans ran into technical problems and then COVID hit, so they had to postpone the launch until 2022. So it's going to land in an ancient Martian lake bed. It'll carry a suite of cameras, spectrometers, and a drill. It can dig up material from 2 meters below the surface, bring it on board. It'll be crushed and into a powder and heated. And there are going to be 4 experiments that will study this material for signs of organic compounds and biosignatures of past or current life. So it's possible that if Mars does have life, the Europeans could beat NASA to the punch, and NASA will have a big egg on its face for not sending a life detection experiment years and years ago. Now, if these robotic missions cannot resolve the life question, they really can't prove that there's no life, they can only prove that there's life, then perhaps future human explorers can dig down into the underground aquifers and other locations that are thought to be the most likely to harbor life. And it really might require a sustained human presence and exploration for many years to really prove one way or another if Mars is a living or a dead planet. And you know, if astronauts or anybody finds evidence of life on Mars, it would be an incredible discovery. If Martian life turns out to have some kind of evolutionary linkage to terrestrial life, it could imply that life originated on one planet and was transported to the other inside a meteorite like ALH 84001, or it could imply that life on both planets were seeded from a common source. But what if Martian life is completely unrelated to terrestrial life? That would strongly suggest that life arose independently on 2 separate worlds. And that would imply that life will arise wherever conditions are favorable. And that in turn would imply, I think, that our galaxy, just the Milky Way galaxy alone, has billions of life-bearing planets and worlds, as I'll explain later. So I want to turn now to the icy moons of the outer solar system. And we're going to start with Jupiter's 4th largest moon, Europa. Now, the 2 Voyager spacecraft, 1 and 2, when they flew by and they saw how much they were deflected by its gravity, they could get a bulk density measurement. We could measure its size and mass, therefore we can calculate its density. And that implied that there's a very thick layer of liquid water underneath this moon's icy crust. So that was really interesting. And in this picture, you see cracks all over the surface. You see very few craters. The cracks imply that there's liquid material from under the surface that's getting up to the surface. So these were very tantalizing that there could be a lot of liquid water on Europa. So starting in 1995, NASA's Galileo spacecraft went into orbit around Jupiter, and it had a number of close flybys of Europa where it took spectacular images like this one. And what you see here is you see these kind of chunks that look like kind of ice rafts that look like they're floating on top of some kind of watery medium. Galileo had a magnetometer that discovered an induced magnetic field on Europa, which indicates that there's a subsurface ocean that's salty. And even more intriguing, Galileo discovered organic material on the surface. All these are really amazing discoveries. And so since then, scientists studying Hubble Space Telescope data and archival Galileo data have found evidence that Europa is shooting watery plumes into space. So you add all of this together, there's abundant evidence for a thick ocean of water on Europa. In fact, the model suggests that this ocean contains more water than all of the water in Earth's oceans combined. And this ocean is almost certainly in contact with a rocky layer below. And we also know Europa is tidally heated from being tugged upon by Jupiter and its 3 other large moons. So Europa has all the ingredients for life as we know it. It has liquid water, organic molecules, and energy. So it's really not difficult to imagine hydrothermal vents on Europa analogous to those on Earth's seafloors, which fuel rich, complex ecosystems in the complete absence of sunlight. So NASA is planning a mission in the early 2030s called Europa Clipper. Now it's going to orbit Jupiter, but it'll fly by Europa 44 times over several years. It'll image almost the entire surface at high resolution. It'll measure the ice thickness so scientists can identify where the ice is relatively thin. It'll also fly through these plumes I talked about and measure their composition. I don't think that Europa Clipper will discover life, but it will pave the way, I hope, for a future lander. So this lander will search for the surface for signs of life, but more important, it'll either melt or drill its way through the ice and deploy a submersible to explore the ocean and look for signs of life. So this would be an incredibly exciting mission, but it's probably a long way off. My guess would be it would launch in the mid to late 2030s at the earliest, but it would be an amazing mission. I want to turn briefly to now Titan. Scientists are keenly interested in this largest moon of Saturn because it has a thick atmosphere that has similarities to Earth, both in terms of composition and pressure. And it has lakes and rivers on the surface where the liquid is not water, but methane. So methane is CH4. It's an organic compound. The problem is that the surface temperature is minus 290 degrees Fahrenheit, which is probably too cold for life as we know it. But there could be hydrothermal areas that are warmer where you could imagine life. There could also be a water ammonia layer below the surface that could sustain life. So NASA has approved an incredibly exciting mission called Dragonfly that's basically a rotor craft or kind of a robotic helicopter that's going to fly in Titan's atmosphere. So it's going to study the surface composition, atmospheric conditions, geological processes, scheduled to launch in April 2026, arrive in December 2034. So you can imagine flying a helicopter in an atmosphere of another planet with very cold temperatures is another incredibly challenging mission technologically. But if it works, it could conceivably find evidence for non-water-based life, life 2.0, life unlike life on Earth, or at least help scientists better understand the origin of life. So now I want to leave the solar system behind and turn to exoplanets, planets orbiting other stars. And I checked the website exoplanets.eu just a few hours ago, and it said that as of today, there are 4,340 known planets orbiting other stars. So that's pretty amazing. That's 542 times as many planets orbiting other stars than we know orbiting the sun. So you can do statistics on what we found, and we can say very confidently that the Milky Way galaxy has hundreds of billions of planets and could be as many as 1 trillion. You add the moons in, and there's just an enormous number of potential habitats for life. But even the closest exoplanet is 4.2 light years or 25 trillion miles away. So you might be wondering, we're not going to visit them anytime soon. How can we study them for signs of life? And this illustration explains how it can be done. We can probe exoplanet atmospheres, and we're doing it right now by looking at transiting exoplanets, the planets that cross in front of the disks of their host stars once every orbit as seen from Earth. So as the planet transits its star, some of the star's light passes through the upper atmosphere of the planet, and some of the molecules and elements in that atmosphere will absorb some of the starlight. So the astronomers can look at the spectrum of the star when the planet is in transit and out of transit, and the spectral lines that show up when the planet is in transit act like a fingerprint, revealing different chemicals in the planet's atmosphere. So these spectral lines could reveal chemical indicators of life known as biosignatures or biomarkers. Now here we see the spectral signatures of Venus, Earth, and Mars as they might be seen from alien astronomers from outside the solar system. Now when they would look at Earth, what would jump out to them immediately is that very clear spectral line for O3. That's oxygen molecule called ozone consisting of 3 oxygen atoms. They'd also be really interested in the water feature, which would show up quite abundantly. That would probably immediately, the alien astronomers would probably think there's a very good chance this planet, of course they wouldn't be calling it Earth, who knows what they would call it, but they would say, you know, oxygen is a highly reactive chemical. If it's not constantly replenished, it would disappear from Earth's atmosphere within a few centuries. So it has to be constantly replenished. And, you know, certainly on Earth, almost all the oxygen is from photosynthesis and biology. So they would probably say this is a extremely interesting planet, probably has life. Now, if they look at Venus and Mars, both of those planets have atmospheres dominated by CO2, carbon dioxide. There are so many different chemical and geological processes, including volcanism, that can produce CO2 that have nothing to do with life. So they would say, well, you know, we can't rule out life on these 2 planets, but they're a lot less interesting than that middle of the 3 planets. There's another way we could find biosignatures as well, and that is to get spectrum of other planets and find combinations of chemicals that should not exist together in the atmosphere, where they would destroy each other, or one or the other would be removed. And so the only thing where you could, you know, the most likely explanation is life, to give you that particular combination of chemicals. So astronomers have already used this transit spectroscopy method to discover dozens of chemicals in exoplanet atmospheres, including water vapor and CO2. But it's generally thought by the community of astronomers that it'll require the next generation of telescopes to really find convincing biosignatures. But the good news is that this next generation of telescopes are right around the corner. One of them is the James Webb Space Telescope, which NASA is scheduled to launch next year, a little over a year from now. It has a 6.5 meter mirror, more than twice the diameter of Hubble's primary mirror, and it'll be optimized for infrared observations, which could reveal water, ozone, methane, and CO2 in the atmospheres of transiting exoplanets. So it's going to observe stars within a few dozen light years of Earth that have transiting planets, and astronomers are going to especially concentrate on planets that orbit within the habitable zones of their stars. Now, I think even better is that international consortiums are currently building 3 gigantic land-based telescopes pictured here, all of which are expected to come online before the end of this decade. So counterclockwise from the upper left, we have the 30-meter telescope. the Giant Magellan Telescope, and the European Extremely Large Telescope. So they all have primary mirrors, 25 to 40 meters in diameter. I mean, think about that. The largest ground-based telescope right now has a mirror about 10 meters in aperture. So these are giant telescopes. They're going to be equipped with state-of-the-art instruments. So they're going to be able to probe a greater number of transiting exoplanets with better spectral resolution than JWST. Because they're located on Earth's surface, although in very dry areas, they're really going to be optimized more for optical observations rather than infrared. So they're going to be capable of detecting biomarkers like O2 and O3 and water vapor. So if life is common in the galaxy, there's a decent chance that one or more of these three telescopes will detect biosignatures. Astronomers are also developing telescopes that use advanced coronagraphs and other techniques that can blot out the light of a host star. The star is going to outshine the planet by roughly 1,000,000 to 1, depending on, you know, the factors of the system and the wavelength. So astronomers need to reduce the star's glare to really study planets that don't transit their stars. So here's what's called ExoLife Finder, ELF. An international team is working on the technology right now. It's going to be a 20 to 30 meter telescope depending on funding. And if it is built and works according to specs, it can probe deep into exoplanet atmospheres and even take images of clouds and surfaces. I mean, it could theoretically image oceans and continents on another planet outside the solar system. And of course, this includes planets that don't transit their stars, which constitute the vast majority of planets in our galaxy. So now for the third and final part of my talk, I'm going to talk about the search for extraterrestrial intelligence, or SETI, but I'm going to also expand this a little bit to talk about technosignatures, which are signs of advanced civilizations that are either modifying their planets or their interstellar environments in ways that our advanced telescopes could detect. So I think, as many of you know, since the early 1960s, astronomers have been listening for alien radio signals using radio telescopes or arrays like the Allen telescope array that we see here. This has been going on for quite a while. The projects right now are mostly piggybacking on routine radio observations of stars and galaxies. The most sophisticated and advanced radio SETI project going on right now is called Breakthrough Listen. It's funded by the Israeli-Russian billionaire Yuri Milner, who we see at the upper left. So it's using these two large telescopes, the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia. And by the way, I visited both of these. These are both my photos. But it's using other telescopes as well. They've released data recently of thousands and thousands of stars. Still no confirmed signals, but they've only, if you take all the SETI efforts up till now combined, they've only scratched the surface, or, like literally barely even, like a needle in a haystack, like searching just a few grains on a vast, beach, ocean beach. So the lack of a signal right now really doesn't tell us anything about the presence of alien civilizations. The searches keep getting better and better. The receivers now can sift through millions of narrowband channels simultaneously. So if there are other radio transmitting civilizations out there, maybe someday one of these SETI programs will hit the jackpot and it'll make big news. There's also several groups that are doing what's called optical SETI, which is searching for powerful laser signals transmitted by other civilizations. There's a group at the University of California, San Diego, that recently installed a near-infrared detector on a 1-meter telescope at Lick Observatory in California to search for these laser signals. They're also working on an even more advanced instrument to install on one of those large ground-based telescopes I discussed a few minutes ago. However, I would bet that if we ever discover other civilizations, I would put my money on technosignatures. And, this of course is, some kind of indication of a civilization modifying its planet or interstellar space. Now, it's really fascinating to speculate about technosignatures because it forces us to consider the activities of civilizations millions of years ahead of our own civilization. So, for example, in this artwork, we're seeing a space colony orbiting a black hole that's tapping the rotational energy of the black hole, which is enormous. So, we're nowhere close to being able to do this. I mean, we might be thousands and thousands of years from being able to do this, or maybe never. But who's to say what kind of astroengineering project a civilization millions of years ahead of us might be capable of achieving? And especially think, what if they have artificial intelligence that can speed things up? We really don't know. So there are a number of ways that astronomers could discover the technosignature of an extraterrestrial civilization. One possibility is that the telescope I told you about a few minutes earlier, Exolife Finder, or ELF, could find artificially produced gases such as chlorofluorocarbons in the atmospheres of nearby planets. Okay, so that would be pretty amazing. But one of the team astronomers, the University of Hawaii's Jeff Koons, said it could also take, in the infrared, do thermal imaging of cities on the night side of planets within a few dozen light years of Earth. So who knows what those cities would look like? Here's some kind of really cool far out art of what one of these alien cities might look like. I'm sure many of you have heard of the term Dyson sphere. In 1960, the great physicist Freeman Dyson, who died just a few months ago at age 97, popularized the idea that a highly advanced civilization could build a spherical swarm of space colonies that would orbit the star to harvest some or most of its radiant energy. So here we see an artwork of what one of these Dyson spheres might look like. Now, such a megastructure would have to give off heat, second law of thermodynamics. So astronomers could detect this heat in the infrared part of the spectrum. And in fact, astronomers have actually studied infrared data of other stars and even entire galaxies to see if they could find signs of Dyson spheres or other megastructures. And this is just, so far they haven't found anything, but this is just one of many proposed technosignatures that astronomers could possibly detect with current or near future telescopes. And we might not even have to look deep into space to find evidence of another civilization. So consider a civilization that arose billions of years ago and that endured for millions of years and developed highly advanced technology way beyond what we possessed. With that immense amount of time that is at its disposal, interstellar travel might be child's play. So one of our own astronomers, Penn State's Jason Wright, has pointed out that we can't even rule out the possibility that advanced civilizations have sent probes to our solar system and we would be completely unaware of them because we have barely even begun to explore our own solar system. So if you think of the book and movie 2001: A Space Odyssey, Arthur C. Clarke envisioned this scenario decades ago when he imagined this monolith buried right below the lunar surface, which, future American colonists discover on the moon. So if we start exploring the other solar system, or the solar system, planets and moons up close, who knows what we might find. And Wright has even pointed out that we can't even rule out the possibility of active or derelict alien probes orbiting the sun right now. Only a very vast and thorough exploration of the vast expanses of interplanetary space would reveal them. So once again, none of this is crazy if you accept the idea that other civilizations might exist, and then some of them might exist for millions of years. If you accept those possibilities as being, you know, something that could be true, we cannot even rule out the possibility that Earth is being observed right now. So I just want to conclude by saying that a conclusive discovery of another civilization, I think, would be a really big deal. If the civilization is far more advanced, which is highly probable, it would give us reason for optimism that even a relatively primitive civilization like ours can survive technological adolescence. And if we can learn something about this civilization, it might answer the question of whether humans have a post-biological future where we might merge with machines or produce artificial intelligence that takes our place. And confirming the existence of another civilization might have profound ramifications in ways we cannot predict, especially if we can get some detailed information about the alien society. And even detecting primitive extraterrestrial life, I think, would be incredibly fascinating. It would give us insight into our origins and the types of planets and environments that can support life, and what kind of alternative life forms might be possible, life that might be radically different from what we have on Earth. But imagine we go decades and search for extraterrestrial life with better and better technology and telescopes, and we come up empty. Even that negative result would be interesting. It might be disappointing, but it would be interesting, but it would imply that something rare or unusual happened here on Earth. So I think that no matter what we find, the search for life on other worlds is going to tell us a lot about ourselves and our place in this wondrous universe. So I want to thank you for your attention, and I will be happy to field questions.
Hey, thank you very much, Robert. Yes, catch a drink of water. That was a good presentation. I have a quick, you can hear me, right?
Yep, no problem. You can still hear me.
So how does Big Joe become your favorite rock on Mars?
I just like the name, and
okay.
And even though my name isn't Joe, and part of it is the Viking landers landed in 1976. I was 13 years old, and I was old enough that I could really appreciate it. Like when I remember the Apollo missions, but I was younger. I was kind of a little bit interested in space, but, very unsophisticated. But with Viking, I really understood, like, we've never landed on Mars before. What does Mars look like? What are we going to find on Mars? I was old enough, because I was interested in science, that I could really appreciate it. And of course, these early pictures from Viking 1, Big Joe was the main rock. And so I just fell in love with Big Joe. Now, I should point out, if Viking 1 had settled down, it's parachuting down. If it had settled down on top of Big Joe, end of the Viking 1 mission. So fortunately, Big Joe, as I remember, is like a few tens of meters or something like that away. So fortunately, it came down near Big Joe, but not on Big Joe.
Right. Do me a favor, Robert. I need you to unshare your screen now. There should be a button somewhere.
Yep.
And normally I'd hold questions to the end, but I thought there's something we can do on this format, everybody, under more. If you have a question, you might try doing what I just did. It should work. You can put like a hand up, or you can put something up that you want to ask a question. Dan, if you're there in the background, can we just unmute everybody for a minute? And then,
sure.
Maybe we could do a question that way too.
Like your background screen there, Ted, with the Roger Dean from like some of the Yes cover artwork. I like
Roxanne Kamen, who's our guest speaker next month, caught that for me too. I told her I was going through a Yes revival listening to this all during COVID. So yes.
Ah, great. I'm a big fan of Yes too.
Well, tell people where your picture's from. By the way, the picture you selected looks stunning while you were doing this talk, especially next to your pictures. But where's that one come from? Your
I
background.
took that just a few days ago, right out my front door of sunrise in over Hershey, Pennsylvania. So I took that, you know, literally, and you know, the first two of these Zoom talks that I gave to two other astronomy clubs, I told Ted earlier, I didn't like have a background, like my background was just my wall. And so I want to thank Ted for showing me how to do this to create a more interesting background.
You know, it looked good. You'll like the video with the playback. You look good on it.
Yep.
It came out
Okay, great.
Okay, let's do this because I know Denise wants to do a little bit of a talk and I have just a little bit lined up. Does anyone have a quick question they might want to try? And okay, Al, go ahead.
And I can stick around until the end and take questions later. And that'll give you a chance to grab a beer too.
Thank you, yes.
I have one of mine. Question and one observation. I was sad to hear that Freeman Dyson passed away.
Yeah.
I didn't know that.
Yeah, I think he died. I think it was in February. But you know, he definitely lived a very.
You should pick it up.
Yeah, he lived a very long and productive life, though. But yeah, he made it to 97, which is. I doubt I'll make it to 97. I don't live a healthy lifestyle.
We all had the joy of meeting him. He commemorated our first opening at Muddy Run Observatory.
That's right. Yes.
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 Exelon foot the bill and actually took him on a limo drive all the way out to the observatory, which was absolutely great. And yes, he was out there. I was going to bring up the Dyson sphere if you hadn't addressed it in the talk, because it's interesting. I had brought a couple of the club members had said that too about, oh, we should play the Star Trek adventure that he was, you know, in. And when I did bring it up to Dyson, he said that the idea, let's just say, played out in Hollywood much more grander than he had imagined it. So he said, I can't really take credit for what came out in that science fiction thing because it was much more grandiose than what I had thought of. And then he also said, no, let's avoid that. So I thought, okay, no problem.
Now, do you have a recording of his presentation? Because if you do, I'd be very interested in watching or listening to it.
Do we, Al?
Dan recorded it, didn't he?
Dan?
I have, yeah, I'll get it to you.
Oh, great.
Oh,
Thank
really?
you. That'd be great. Yeah, I'd love to hear what he had to say. I mean, I haven't read any of his books recently, but I remember maybe like 20 years ago, I read his book, Disturbing the Universe, which was really interesting.
Well,
Dan, think about this. We could do a commemorative about him. I'm sorry, I'm talking over Al, but we could talk. We could post that video link to Dyson, the talk we had done, and just do it as a commemorative. We could put it on the Muddy Run site. We could also put it on our site.
Mm-hmm.
I'll talk to Dan about it afterward during the week, and we'll see if we can't figure out how to get that to happen. But yeah, that was kind of interesting. That was a highlight of me being a president here because I was scared to death to talk to the guy. I really don't understand all of his work. And okay, so my members have heard this, but I walked in with the book Physics for Dummies. Mm-hmm. And I put that on his desk and I said, Freeman, I said, I get lost somewhere around chapter 13, 14. I said, even I can't get through this book. And he was good with it. He bonded with me in a different way. We had fellow friends that helped him build the observatory. He built an observatory up in Washington Crossing State Park for the Princeton astronomers.
Oh, wow.
He was a bricklayer and he actually built the foundation. And that's why he came out to Muddy Run, because he said to me that one of the most amazing things he ever did was build the observatory, and it lasted longer than any of his ideas did because it's like 60 years old now. So.
Oh, wow. Congratulations.
It was a lot of fun. Yeah. It was a lot of fun meeting him. So, Denise, are you out there somewhere?
Well, I think Alan had a question.
Oh, okay. Go ahead, Al.
Okay. Can you guys hear me all right?
Yeah.
Yeah, okay. No, it's not really a question. It's more of a comment. All this big deal about Venus and stuff. I think Venus is kind of like practice getting ready for this transit spectroscopy, because if this had happened with transit spectroscopy, everybody'd be going nuts. But with Venus, we can do more easily, follow-ups with landers and, just atmosphere samples. Just a comment.
No, I agree with that. It was interesting because the article I wrote for Astronomy magazine, I had 3,000 words, a lot of ground to cover. So I was aware, I wasn't aware of this result, but I was aware that there's been speculation dating back to Carl Sagan in the 1960s that there could be life in the clouds of Venus. But I decided I don't really have room to cover that in the article. So I kind of feel like, you know, so the article comes out and a couple weeks later, oh, we may have found life on Venus. So I kind of feel a little bad about that. But, you know, the scientists, I did email several scientists just, you know, last week after the result came out. And, you know, I've gotten mostly, you know, no one's, you know, the general view was we think that the phosphine detection is probably okay. You know, it was made by 2 different telescopes, but it was only made at in one region of the spectrum. So there, you know, there's questions about how robust the detection is, although it's probably real. But, you know, the message I was getting from these scientists, one of them is Chris McKay at NASA Ames, is we know almost nothing about the chemistry of that particular layer of the Martian atmosphere, other than there's not a lot of water at that altitude, but there's a lot of sulfuric acid. There could be all sorts of other trace compounds that, you know, the mixture of the chemistry there could produce phosphine. So you can say, yeah, phosphine is on Earth. It's definitely a biomarker for Earth, but we just don't know right now about the chemistry of Venus's atmosphere to really rule in or rule out life right now. So I think it was not irresponsible of the team to announce this, because they made it very clear we are not claiming we discovered life on Venus. They needed to throw the result out there so other scientists are interested. So like NASA and ESA, you know, Japan, China, and other countries that fly interplanetary missions get interested to do a follow-up.
Right.
So I would say it was totally okay for them to do what they did. But if I had to bet money, I would bet that they probably did not find life. But I would not want to bet a lot of money against it. It's possible that they did. And, you know, it could be it's sort of a primer with the exoplanets.
Yeah,
You know, we can find things that would say, okay, there could be life there. But, you know, once again, if you find a planet that's the right size in the habitable zone, and you find things, let's say, like Earth, or certain combinations of chemicals, you might not be able to prove that there's life, but it would probably be, especially if we start finding a whole bunch of planets with similar signatures and they're all in the habitable zone, and let's say planets that aren't in the habitable zone don't have them, you start getting things like that, and you're going to probably say, okay, we can be pretty confident we found life. My guess is the first 1 or 2 planets that they might think they found life, it might not be that convincing. But if you start building up like an inventory of like a dozen planets, then it starts getting pretty compelling. That's how I kind of see it unfolding. Does that make sense?
Thank you. Yeah, fine.
And you made
Thanks for
your comments, very, very well taken comment.
Yeah, okay. Well, thanks for, you know, being at our meeting.
Yep.
Appreciate that.
My pleasure.
Well, hang in there with us, Robert. I'm going to hand it over to Denise, I believe, now.